Hello! In this video we will discuss stepper motors, their working principles and how to control one with an Arduino. Stepper motors are in principle brushless DC motors, but instead of rotating continuously, they only rotate a set increment at a time, called a step. Steppers are controlled with pulses, where one pulse corresponds to one step. A common configuration for steppers is 200 steps per revolution, which translates into 1.8 degrees per step. The angle between two steps is called the resolution. For specific use cases, also more precise steppers are available. For example, 400 steps per revolution. Contrary to DC motors, stepper motors offer very precise control of movement. They also aren't restricted in the angle of rotation in the way most servo motors are. Additionally, stepper motors prevent rotation by holding their position. This means that they draw current even when not rotating. Therefore, it's no surprise that stepper motors are chosen in high-precision applications, for example 3D printers and CNC machines. It is possible to drive a stepper motor only with an Arduino, but we recommend using a stepper motor driver. In the example coming up, we will be using a DRV8825 stepper motor driver. Stepper motor libraries also exist, but we won't be using one in this example. We are now demonstrating how to control a stepper motor with an Arduino. To follow along, you will need an Arduino, a breadboard, a stepper motor, a DRV8825 stepper motor driver, a capacitor, some hookup wires, and a 9-volt battery. First, connect the motor driver to the breadboard across the notch. Connect the motor first, then the Arduino, and lastly the battery. It's important to connect the battery last, as supplying power to only some pins or the wrong ones can break the motor driver. The code used can be found in the description of the video. First, the pins of the motor controller are defined and modes set. We define our own step function, which accepts the direction as a parameter. In the function, we write first to the direction pin and then send a pulse to the step pin. In the loop, we used the step function inside a for loop to send multiple step calls to the motor. In this case, 200 steps clockwise and then 200 steps counterclockwise. The stepper motor consists of a rotor and a stator in the same way as DC motors. The stator is static and is a part of the motor housing. The rotor consists of a permanent magnet and the rotor shaft. The magnet is divided into two so-called rotor cups, separating the north and south poles. The rotor cups, the magnets, have small teeth which do not align between the two cups. The stator consists of electromagnetic coils, which are also lined with teeth. The coils are usually divided into two phases named A and B. Powering one of the phases makes the teeth of the stator pole attract the rotor teeth with opposing polarities. This makes the rotator turn and take one step. When the teeth are aligned with the currently powered phase, they will be a bit off from the next phase. Powering the next phase will thus make the motor take the next step. To rotate the motor continuously, the phases need to be powered in a specific order. When a phase is powered, the motor won't move until the power is turned off or the powered phase is changed. There are several ways of driving a stepper motor, for example only powering one phase or powering many phases at a time. Full stepping offers the highest torque, when on the other hand micro stepping allows smoother control. Stepper motors are divided into two categories, unipolar and bipolar. In bipolar motors, the phases only have a single winding. This means that a more complicated circuit, usually containing an H-bridge, is required when the current needs to be reversed. Bipolar steppers can usually be recognized by having 4 wires, as one phase has one positive and one negative terminal. Unipolar motors have a center tap or common wire for each winding. This allows the current to be reversed in the winding without changing the polarity of the common wire. Unipolar steppers usually have 5 or 6 wires. The phases have 3 wires each, but in some cases the common wires are connected together. Bipolar motors offer more torque and better efficiency, but require a more complex circuit or motor driver than unipolar motors. With motor drivers being so cheap and easily available, bipolar motors are often preferred. That's everything for this video. Thank you for watching and see you in the next one.